Okay, we're going to talk a little bit about current paths here. So, got a person, a little resistor there because we all have resistance. And he's got a drill in his hand. And it's a 120 volt drill. It's plugged in. Now, we're standing on concrete, and by the National Electrical Code, concrete is ground. So, we're grounded, all right? You can't see the green too well, so I'll use black. We'll draw the ground. A little better? Yeah. Okay. Now, he's plugged in. You're drilling a hole. We're grounded, and this ground wire runs back to a solid ground at your panel, okay? So, here's your electrical panel, okay? 240 / 120 single phase in your home, okay? Now, this drill shorts out. Let's say it's a metal case drill. It's the old one your daddy got, okay? It's grounded all the way back here. As soon as it shorts out, it's going to trip breaker, right? The question is, will you get shocked? I bet I've given this to over 2,000 electricians over the years. And whenever I ask this question, they go, wow, that's a great question. I never thought about it. Most of them do. I never thought about it until I had to start doing training and arc flash training. The old saying is, current takes the path of least resistance, right? You learn that in circuits 1, circuits 2. You learn it for a reason, but don't ever say that again, because current takes all paths. Just like I was talking about in the first safety video, where if you're watching TV and your wife or significant other's turning on that 3 gigawatt hair dryer, which one has lower resistance? Well, it's the one that takes the most power. The 3 gigawatt hair dryer, when you turn it on, there goes your TV, there goes your lights, there goes the neighborhood, right? But we know that doesn't happen because everything runs together. Current takes all paths. Now, here's where it gets interesting. Here is the electrical symbol for a circuit breaker. In fact, it's a single pole circuit breaker that feeds all your 120 volt outlets. Now, on your circuit breaker, if you get a direct short out on your circuit, it takes 6 to 8 cycles to trip. Okay? 6 to 8 cycles to trip. Excuse me. So, we have 60 hertz, right? So on 60 hertz, 6 cycles is 0.1 or 1/10 of a second. Now, how fast does electricity go? What's the speed? It's speed of light, right? 186,000 miles per second or 300 million meters. So in 1/10 of a second, electricity travels over 18,000 miles. So 6 to 8 cycles, it'd be between 0.1 and 0.15. So we're talking over 20,000 miles electricity goes in the time it takes that breaker to trip, because it's an inverse time breaker. It trips on heat. And it has to, the physics of it, it has to heat up before it can trip and open the circuit. So during that 6 to 8 cycles, that 1/10 of a second, yes, the answer is yes. You will be shocked and you can possibly be killed even though the breaker trips from this fault right here, because current takes all paths. And that's why there's certain safety habits that you watch old electricians, they'll rarely ever walk up and touch a panel when someone else is working on it. They rarely will walk up and lean against an electrical panel when someone's working on it. In fact, some of them won't lean against one and nobody's working on it because they know what can happen. If something shorts out in that big old electrical panel, that metal, is going to be hot for 1/10 of a second or maybe longer. So being hot, they are another path to ground. Current takes all paths. You can get electrocuted from something shorting out. Just like the old saying is, if you got a thunderstorm, you don't want to sit there and hold on to a screen door, or you don't want to sit there and hold on to a water faucet. You know, if you get a direct hit, current takes all paths, it's going to look for every path to ground. Okay? So, the answer is yes, you will be shocked. You could be killed. Yes, the breaker will trip, but it takes over 1/10 of a second, or at least 1/10 of a second for it to trip. And during that time, current's taking all paths because that breaker is trying, it's heating up, but it can't trip. I hope this makes sense, and let me know any questions you have.